Hello, everybody. Welcome back. This is chapter 5, and this is the solution chapter. And solution is kind of a long word, so I am probably going to go ahead and abbreviate solution as SOLN, and aqueous will just abbreviate as AQ. So, what is a solution? A solution is a homogeneous mixture. And remember, homogeneous just simply means that it's exactly the same composition throughout. So it should be well stirred, well mixed. Every drop of the solution should have exactly the same concentration. The solution itself is made up of two parts. It is made up of a part we call the solute, and oops, if I can spell. And there may be more than one solute, and the other part is the solvent. And the definition of the solvent is it's the larger component, and the definition of the solute is it's the smaller components. So you can only have one largest component, so that's the solvent, but everything else is the solute. And so some examples of some solutions here. So for instance, brine. So if you like olives, right, they're often pickled in brine. They're often stored in brine. And brine contains a little bit of salt. So sodium chloride dissolved in an awful lot of water, so H2O. So that's an example where the solute is a solid and the solvent is water. Now, you might also hopefully be breathing, and so you're probably breathing in something like air. Air is a homogeneous mixture. It is technically a solution. And the largest component of air is nitrogen. About 78% of the air is nitrogen. And about 21% of the air is oxygen, so it classifies as a solute. And about 1% of the air, that is in dry air, is argon. There's a little tiddly bit of carbon dioxide. There's a little bit of water vapor in dry air. Of course, we remove that. There's a little bit of things like neon and helium and hydrogen, just a very tiny trace amounts. But the three biggest components in our solution here are nitrogen, which is the largest, hence the solvent, and oxygen, the second largest, and argon, the third largest. So those are the solutes. So these are all solutions, and we have a technical term here. Whenever the solute is, whenever the solvent is water, we call this an aqueous solution. So aqueous means essentially water is the solvent. And so most of the solutions in our general chemistry lab are going to be aqueous. Water is sometimes called the universal solvent. It's very good at dissolving most things. And of course, in our body, water is present in the largest component. And most of our body is comprised of aqueous solutions. So there we go. That's the introduction to solutions. We have some terminology that goes with solutions, and a lot of these I think are fairly commonly used outside of the chemistry lab, but I'll give somewhat precise-ish definitions, if precise-ish is a word. We have dilute solutions. Dilute solutions are one where there's a low ratio of solute to solvent. So it just means there's a lot of solvent, there's a little bit of solute, that is dilute. And so if you just sprinkle a little bit of salt in a whole bunch of water, that would be a dilute solution. And the opposite of dilute is concentrated. And so concentrated is essentially the ratio is flipped so that there is a high ratio of solute to solvent. So if you dissolved a whole mess of salt in water, that would be a concentrated solution. We also have some other terms as well. So we have unsaturated, which is where essentially more solute can dissolve. In a given amount of solvent. And the saturated solutions are ones where we've actually got the maximum amount of solute that can dissolve. So the max amount of solute that can dissolve. And technically, these should be in a specific amount of solvent. Oftentimes, we use 100 grams of solvent, and so an unsaturated solution would be a point where more solute can dissolve in that 100 grams of solvent. A saturated one would be the maximum amount of solute that can dissolve. And actually, if we take a case of brine, it turns out that brine at room temperature, you can get 36 grams of sodium chloride to dissolve in every 100 grams of water. So an unsaturated solution would essentially be any solution that could hold more solute. So anytime you've got less than 36 grams of sodium chloride in room temperature water, that would be an example of an unsaturated solution. And there are solutions that are super saturated. And you might think, well, you can only have unsaturated or saturated, but you can actually have a class of solutions called supersaturated, and these have more than the max amount of solute. And, well, what's the point of having a maximum, right, if you can exceed it? And the thing about supersaturated solutions is that they are unstable. So, not unstable in the sense that they will explode, but unstable in the sense that if you somehow get more than 36 grams of salt to dissolve in water, which you can do that by boiling the water, and then you can add maybe 40 or 50 grams of salt, and you can let it cool down slowly to room temperature. That extra 14 or so grams of salt can stay dissolved in the water as it cools down. But as soon as a speck of dust falls in, or as soon as there's a little scratch on the side, which sometimes we initiate with a glass rod, or, if you just look at it just wrong, that extra stuff will crash out of solution. And so honey is an example of a supersaturated solution of of sugar in water. And you know that if you have honey that stays on the shelf for too long, the extra sugar crystallizes out. Let me see if I can dig up a video of these processes. Alright, so this is a YouTube video here of a solution of sodium acetate, and this solution has been made by warming up some water, boiling some water, and adding sodium acetate and letting it cool down very slowly. And the flask it's in is extremely smooth. There's no dust or specks of anything allowed to fall in there. There's no scratches. And so this solution can stay with a higher concentration of sodium acetate than we would expect. So it's super saturated. I'm going to push play in a minute, and what we're going to do is we're going to let the solution, we're going to drop in a seed crystal and watch what happens.
Okay, just really quick, I'm going to add one tiny seed crystal. I'm not sure if you can see it on the tip of that scoopula there. Right at the tip, we're going to add that to my supersaturated solution of sodium acetate. And we will see it go from a supersaturated state to a saturated state in just a few seconds. Isn't that cool? So we see that the sodium and acetate ions recognize the crystalline structure of that seed crystal I just added. And they add to it. And we form one big crystal. Now when I tilt this to the side, you can see it looks like a big chunk of ice, doesn't it? So now we're back. There's a little bit of water in there. You might be able to see it, but we're back to our saturated state right now. So we've gone from supersaturated to saturated in just a couple of seconds. All right, hope you like that. Bye-bye.
Wasn't that cool? So sodium acetate. So sometimes you can buy this stuff in little plastic bags, and there's a little clicker inside. And what you do is you boil the bag in water to dissolve the sodium acetate to make it super saturated. You let it cool down. The plastic itself is so smooth it never crystallizes. And when you're ready, you click the metal clicker inside, and it exposes a rough edge that gets this process going. And the reason we do this is this actually releases quite a lot of heat. So you can have them as little heat packs that are reusable up to a point. So I just wanted to show you that video because I thought it illustrated the point of a supersaturated solution very nicely. Thanks.